So what I find that students tend to struggle with when writing a proof is they don't really know where to start. So here's a strategy guide for proving congruent triangles, but you can basically apply this to any kind of proof. It's just that what you're aiming for might be a little bit different. So the first thing to always do is always think about what you're given, okay, and try to come up with conclusions from that. So for example, um, so explaining the given, right? So if they tell you that something is the midpoint, that means that we have two congruent segments. If they give you a bisector, that means that you again have two congruent segments. If they give you an angle bisector, that means that you end up with two congruent angles. If they give you perpendicular lines, that means that you end up with a right angle. If they give you that you have an isosceles triangle, that means that you have two congruent sides of that triangle. If they give you that a line is an altitude, that means that two of the sides are perpendicular. If they give you that something is the median, that means that it implies that it's meeting at the midpoint. And if they give you that something is a circle, then you can know that all the radii of a circle are congruent. So start with the given and figure out, like, interpret it. What does that tell you? Okay, so that's what you can start with. And once you've done that, then you can look at what else that you have. So for example, if the given is congruent, but the parts are not parts of the triangle that you're trying to prove are congruent, then you can try the addition postulate. If the given parts are too small, so you want to add two parts together in order to get parts that are still congruent. You can also try the subtraction postulate if the given parts are too large. So you can subtract congruent parts from it to make smaller parts that are still congruent. Or you can also use supplementary angles if the given angles are exterior. Okay, so that means that, remember, in a linear pair, when you have if a line is split up into two angles, then these two angles are going to add up to 180, or you can also call them supplementary. Okay, and if there are no more givens, then what you do is that you want to look at the picture and see if the picture gives you, for example, a reflexive side or reflexive angle. And remember, reflexive just means that you have the same side being congruent to the same side. So for example, in a triangle ABC, you could say that the side AC is congruent to the side AC. Or you can also have reflexive angles. So for example, angle A is congruent to angle A. And right now in my example, that might seem a little bit silly unless they have maybe an overlapping angle or an overlapping side, okay? So we might use reflexive, we might use vertical angles. So in case you don't remember what vertical angles are, they're angles that are formed when two lines intersect and they're across from each other. So this angle would be vertical angles. And we know that vertical angles are always congruent, okay? And lastly, in a triangle, if two sides of a triangle are congruent, then the angles opposite them are also congruent. So we're talking about two sides of a triangle be congruent, which means that it would be an isosceles triangle, right? So an isosceles triangle, two sides congruent means that the angles opposite them. So the angle opposite this side would be this angle right here, and the angle opposite this side would be this angle right here. So if we have congruent sides, then the angles opposite them are also going to be congruent. So that means that in an isosceles triangle, not only are two sides congruent, but two angles are also congruent. So that would be basically the strategy that we would use in order to prove that triangles are congruent. So